Being on call is not easy, and so does writing software. Being on call is not just a magic solution. Anyone who has been an on call can tell you that. It's quite stressful. You could be woken up at the middle of the night and be under a lot of stress, even if nothing happens. But there are ways to mitigate that. While having software developers as on-calls has its benefits, in order to preserve the benefits, you should take special measurements in order to mitigate the stress and the lack of sleep and the missing work-life balance that might be coming with it. It might not, but it might as well come with it. And again, even if there are no problems, the fact that someone should be available, and many software developers can tell you that even if they are not even being contacted, even just the mere thought and the mere experience of being available 24/7 has its toll on them. But on the contrary, a software developer who is an on-call gains many insights into troubleshooting and the responsibilities and the deeper understanding of the code that he and his peers wrote. Being on call has become a natural part of software development life. Please note that I do not call software development software engineering because I think in order for software engineering, for it to be software engineering, a different process than the one which is taking today should be taking place. But this software engineering progress, unfortunately, is less answering the needs of most businesses today. So most businesses today need software development and not really software engineering. But just like software developers are much more encompassing the end-to-end testing and pieces of software that they write, and just as today software developers are responsible for the cloud, for the installations, for the deployments, and for the product, and just as they work on actual microservices which make a single team responsible for a single or multiple services, so with the advent of the fast internet, the mobile phones, the chat applications, the VPN connections, and the replacing of developers' desktops with laptops, this also meant that software developers today are also responsible for the support and technical aliveness and stability of the software they write. This is actually great and can make software developers and the life of software developer much more enjoyable. And we should incorporate this in the on-call process because this whole process is a holistic part. And the inherent part of all this software development process is also the fact of being an on-call. And also, most of the FANG giant companies such as Netflix, as of today, and the industry leaders do have their software developers as on-calls and respond to incidents happening on the software and incidents they write. So let's see the right approach into incorporating the on-call process into software development so that everyone are happy, both the software developers and the company, and of course, the end clients and customers. You could ask, of course, with all the automation that we have. After all, it's software that we actually develop. And this software is the automatic process in many cases of what was originally a manual process. So how come we still don't have the capability to make all the on-call duty just as we make automatic software that are resolving the problems and making the on-call effort to a minimum? This is not just a wishful thinking of a software developer. In fact, in many organizations, each second of downtime results with the loss of a lot of money. And the difference between a short outage to an hours long of an outage, the time that it takes to resolve a problem is in fact, as of these days, can result with a loss of millions of dollars. So how come this problem has not been resolved automatically yet? How come we still need a man in the loop resolving such issues, which when the compiler, which you can claim does so much of a complex work and process, how come it does not need a man in the loop and resolving sometimes what would seem a much simpler work than the compiler does need a man in the loop? The case is this, that with all the automation testing, with all the monitoring that we have today, and the systems that we have, they are still very complex. They have become much more complex than they become before. So even a simplistic system that you can see, that you can think it's simple, it's very, very complex. It is said that the terminal window, for example, as of today, when you open the terminal on your Mac, let's say the item 2 or the standard terminal that is provided with your Mac OS, then it's actually slower. And with all the computing power that we have gained in the recent centuries, we today have a slower terminal. It's slower than the terminal that we had 20 years ago. This is all a result of the increased complexity that we introduced into our systems. The more computing power that we have, the more complex and the more people are involved in creating these softwares. So the fact that we still need a man in the loop is a mere fact of the fact that we need much more complex software involving a huge amount of developers and teams and complexity and ever-changing specs. The designs of the library versions and the source code versions, the introduction of new libraries and new versions of source codes and updating configurations, all these contribute to the increased complexity that you would eventually be paged at 2 a.m. with an issue. And in these cases, you need to know what to do fast, because as we said, this can result with the loss of a lot of money to the business. There is no magical visibility and monitoring tool for your data that you should collect that would resolve the problems. However, when collecting and visualizing your data and processes, it's best practice if you could focus on being able to understand the flow. Being able to drill down from larger problems into details and being able to run SQL. Yes, SQL, being able to run SQL on your problems, being able to run SQL on your requests, and aggregations on the request and responses is a key factor in easy troubleshooting. Good visibility means you have all the tooling that you need in order to understand the state of your system. There is a balance in between too much of a monitoring and too little, between good and bad monitoring. Good monitoring allows you to quickly triage problems and to differ between major and minor issues, between the ones where your system is responsible and between the ones that microservice number 2 is responsible for. Good monitoring would provide you with the errors that happened at the time of the crisis, with the latency of the system and with the response time of each and different service. One of the most important properties that I would recommend is having a complete view of the flow. If you could take those requests that failed and actually see the actual flow of them, what happened at each stage, the latency in each stage. What failed? This might be one of the most crucial ways for you to triage and identify the problems. What component caused the site to break? Whether you should involve more people or it's solely inside your component that you can know how to fix. How badly does it affect customers? You have usually a few minutes for this initial investigation, 15 minutes maybe. So the tools that you should have are the tools that should help you. You should practice and get used to the tools so that when there is an error, you should not do this process for the first time that you are troubleshooting the problem. So it's best to utilize these tools as part of the development and the testing cycles and analyzing new features when you develop them so that you provide it to production so that if an error occurred, you have already practiced how to troubleshoot it. When you develop a feature, ask yourselves, how do I know that it's working? What if not? What are the metrics that are changing inside the flow? How do I see these metrics? It would be hard to go through the logs and understand if a feature works or not. It is better to have dashboards and graphs and summaries and databases that could contain automatically the data of the processes that happened. And as we said, we want to have an actual view of the full flow of the requests to understand the flow of the system. This would give you eventually the visibility that you need. These overview dashboards usually allow in many companies to quickly glance into the state of the system and help to determine the severity of the errors, to correlate feature commits to errors, so that when an error happens, you are able via a dashboard to quickly correlate it to traffic shape changes, to code commits, to database data changes, to upgrades, to deployments, to changes in client requests, to changes in configurations. If you are able to do this correlation, then you are in a good shape. If it's going to take you time, then not. As an on-call, a procedure for responding for errors could be a developer's best girlfriend. And whenever an error happens, you should do a post-mortem and see if the procedure helped you or hindered you to identify the problem. And of course, the more data that you have in these notebooks, the higher the time it's going to take the on-call to refer to them. So it's best to keep those kinds of on-call procedures like a small cheat sheet. Just like you have a quick cheat sheet to try to organize the on-call procedures in this format. If possible, in one single sheet to capture all the procedures, it's best. Communicating during an issue is an important aspect of the visibility and for future proofing of what happened exactly. You should stick to logging everything you have and any analysis in the problem in one place so that others could learn from these procedures that you have taken. In future, someone would have a similar error. If he has this error, wouldn't it be great if he could just search through the past errors and find how to work around it? It's important to keep updating on the issue, depending on the severity of the issue so that everyone knows what is the state and to see that you focus only on mitigating the problems and not the root cause of the problems. Because the root cause is not solved at 2 a.m. It's not solved as part of this initial mitigation. We are working on the scale of minutes. And if not, then we should see how can we work in scale of minutes. You should mitigate the problem, you should now have the support hat and not the software engineer hat. The problems that you are trying to solve is mitigation and overcoming them as fast as possible. The software developers should take then a step back the day afterwards or the week afterwards and work on the root cause of the problem during a regular sprint. The root cause analysis and solving is too important to be solved as part of the on-call shift, and it should be part of the software development standard flow. First, get the system back into stability. If you search Google for 60 seconds performance analysis, you would find a great Netflix post about how to check if a system is performant and how to find performance issues in a system in 60 seconds. This is a great example of a great cheat sheet for finding problems and for the scale of it and for initial troubleshooting. And it is not a coincidence that the same company that perfected the Chaos Monkey has come up with a 60 seconds procedure blog post for finding performance issues. A system without changes usually have a very limited set of problems, if not any problems. Almost any problem I saw was caused by a change. The change could be a traffic shape, a spike of a change, a code change, a configuration change, or deployment change, or dataset change. When reaching the phase of resolving the actual problem, this is when you look deeply into the change that happened and ask how would it be possible not to have such a problem next time we introduce a similar kind of a change, or even better, how could we improve this visibility and to simplify at the same time the dashboarding, not only to add but also to simplify the dashboarding and the procedures such that such changes would be easily correlated to the problem. Making sure the problem won't happen again requires time. But it's time that you're going to gain with high dividends in the future. Every time a problem is not root caused solved, no matter how much effort and time it takes, it's going to consume so much time. It's like you take a loan. You take a loan on the future time of the developers. You don't want to take that loan. You want to invest in the time of the developer so that they would move even faster in the future. If you don't, you will lose the software development game. When all is solved and the stability of the system is the best indicator of how healthy your organization is. The more stable the system, while being able to develop new features, the happier everyone are going to be. But this requires a lot of examination. The root cause analysis and the follow-up stories and tasks are one method which could be great if you are a team or a few people, is that along and as you have the issues, then one person is continuously working on reducing any downtime. At first, this may seem like a lot because you are dedicating one person every sprint into dedicating his time in improving the stability of the systems. But this is an effort for a time sharing. You invest this time that you would get paid out in the future. If you invest all your time only in development and then also on problem resolving and not investing the time on the root cause further on, not as part of the on-call, then you would find sooner than later that your time is misspent on the quality loan would consume your development time. I want to begin wrapping up. Troubleshooting problems as on-call is not simply having ships and assigning developers to it. It's something that you should plan carefully, and the result of this process is that you have happier developers that can move forward with development, while on one hand, being able to troubleshoot problems as fast and as early as possible, and on the other hand, introduce the least amount of issues and be able to quickly find issues once happened. Once an issue has happened, this is a great opportunity for you to examine the state of your system, the health of your overall organization, and for you to quickly turn this into a task that software developers can then work on in order to ensure that it won't happen again, at least in the most cases, or find the root cause and the ability to mitigate it quickly and continuously improve this as the software lifecycle continues. So I hope you enjoyed it. I did. I will see you next time.